Russia will do anything to win the space race with the US and Europe. While it has been overshadowed by the exploits of NASA in recent times, the country is not giving up yet. In fact, Russia now has a game-changer that will seriously boost its space fortune, a brand new nuclear spacecraft. The whole space industry is shocked because they did not see the nuclear spacecraft coming. However, can Russia really pull off this nuclear reactor-powered spacecraft, or is it biting off more than it can chew? What does Russia's new nuclear reactor spacecraft offer, and how will it help the country to go on top again in the space race? Most people watching this video are not rocket scientists, but they most likely appreciate the complexities of rockets. They are high-stakes investments because they are usually expensive and have the potential for spectacular disasters. In fact, countries compete for supremacy by showing off what they can do in space, and when it comes to the space race, there is one country that has been on the decline. The US's NASA is known over the world for its numerous space exploits, including really ambitious ones. It is currently planning a return to regular missions to the Moon, which will form a stepping stone to bigger missions to the Red Planet. The US is also home to a host of private space companies like SpaceX and Blue Origin that are redefining space travel. China is also coming up strongly in the space race thanks to a recent focus on rocket research. Banned from accessing the International Space Station, China is building its own orbiting station and has already dispatched its astronauts or taikonauts there. However, even before this, China has landed its own rover on Mars, becoming the second nation to do so. It also landed a rover on the dark side of the Moon, a hitherto unattained milestone in space exploration. All these are happening while Russia seemingly watched as other nations overtook them. From being the first country to send an Earth-orbiting rocket to space, Russia has now been relegated to an also-ran in the space race. However, sometimes a sleeping giant wakes up. It is staging a comeback in the loudest and biggest way possible by sending a nuclear reactor-powered spacecraft to space. When it comes to nuclear power, Russia is one of the global leaders. The first nuclear power plant to supply electricity to the grid was situated in Russia, in a town called Obninsk in 1954. The plant was shut down in 2002 due to economic reasons. It became more expensive to maintain it in working condition. However, the plant is enough to ensure Russia's place in nuclear history. Russia is now set to make history again with the launch of a spacecraft powered by a nuclear reactor. It unveiled the new rocket called Zeus, which is destined for destinations in deep space, including Jupiter. Powering spacecraft in deep space is a big deal. This is because of the massive distances these spacecraft have to cover. For instance, using a conventional spacecraft powered by standard fuel, a trip to Mars could last 18 months. That is a long time for any human to be exposed to the harsh realities of space travel. If weightlessness does not harm the traveler, he or she will be bombarded by harmful radiation. In fact, because of the vast distance, some destinations are just off limits with current spacecraft. But nuclear-powered propulsion can help massively in this regard, and this is what Russia is banking on. Its mission is now to send a nuclear-powered spacecraft first to the Moon, then Venus, before taking on the arduous trip to Jupiter. The country's equivalent of NASA, Roscosmos, announced it was building a space tug, the name it gives to spacecraft that transports astronauts or equipment from one orbit to another, which is a very ambitious launch time frame. As mentioned earlier, the new spacecraft is named Zeus. Thanks to the nuclear reactor that is on board, you can refer to Zeus as a mobile nuclear power plant. Of course, the reactor that will power Zeus does basically the same thing that a conventional nuclear power plant does on Earth. It will generate energy from radioactive material, and the energy will be used to propel the spacecraft. Without using carbon-based fuel, a spacecraft could rely on solar power or gravity to accelerate. However, that is a very slow way to travel and is not practical. A round trip to Mars could take more than 3 years. But with a nuclear reactor powering Zeus, the Russian spacecraft could cut up to a year from the trip. Another problem with powering spacecraft with solar energy is that as the spacecraft drifts further away from the sun, less sunlight will reach it. Naturally, it gets darker the further from the sun you go. However, with a nuclear reactor, you can generate energy anywhere in space. Cold does not hamper their operation either. Nuclear reactors can also produce energy reliably for a long period of time. Zeus can draw power from its own nuclear reactor for between 10 and 12 years. Sure, Russia is not the only country to think of shipping a nuclear power plant to space. The US, for example, plans to put a nuclear power plant generating 10 kilowatts integrated with a lunar lander on the Moon. but it wants to do so as early as 2027. NASA has done this before when it sent a nuclear reactor to space on a satellite in 1965. Other spacecraft by NASA have used nuclear power before, including the two Mars rovers Curiosity and Perseverance, but they don't use a reactor. Likewise, NASA's famous duo of Voyagers uses radioisotopes to produce power, but it's not the same thing as mounting a nuclear reactor on a spacecraft. But they have been reliable enough to keep the two spacecraft in communication with the Earth after traveling billions of miles and spending more than 4 decades in outer space. Cassini is another NASA probe powered by nuclear energy. It is still carrying out exploration of Saturn and its moons. But of course, when it comes to nuclear reactors in space, you have to give it to Russia. The country has sent more than 30 to space. Zeus is just extending the legacy by using a 500-kilowatt nuclear reactor to move from one planet to another. Zeus's itinerary in space is rather interesting. We said earlier that the spacecraft would touch 3 space objects, and here's how it will work out. Zeus will head to the moon before striking out for Venus, which it will use to shift the direction of its motion towards its ultimate destination, Jupiter. This nuclear reactor-powered jaunt in the cosmos will take 50 months or more than 4 years. What Russia has to do now is to calculate the flight's ballistics or trajectory and determine the amount of weight it can carry safely. Of course, Russia is not stopping at just building a nuclear reactor-powered spacecraft. In fact, Zeus is just a precursor to a new age of Russian space exploration powered by nuclear energy. Russia is also planning for a complete space station powered by a nuclear reactor. Russia will surely be accelerating its plans for the new space station, following its threat to pull out of the International Space Station due to the crippling sanctions imposed on it by Europe and the US because of its invasion of Ukraine. However, even without the sanctions, the ISS is set to be decommissioned within a decade unless NASA extends a lifeline, so it is high time Russia started thinking about its own space station. It's most likely that Russia will have the field of space travel powered by nuclear reactors to itself for a while, as the US, its main rival, has banned the use of highly enriched uranium to propel objects into space if a mission is possible with other nuclear fuel or non-nuclear power sources. Russia apparently has not self-imposed such limits on itself, so it will continue to research and develop in that direction. The Zeus module would be available to power any Russian spacecraft meant for long trips. Meanwhile, Zeus will prove to be useful for Russia in protecting its interest on Earth. The spacecraft can be equipped with equipment that detects air targets from the orbit. It will relay information about enemy aircraft to Russia's anti-aircraft systems. However, apart from Zeus, Russia signed an agreement for the design of another space tug called Nuclon. This space tug will be designed by a company named Arsenal at the cost of $56.7 million. The project will be delivered in July 2024. Of course, there are many challenges that Russia has to fix before it can blast a nuclear reactor to space on a mission. The highest priority is ensuring the safety of the spacecraft. The launch is a particularly vulnerable period as any error can have fatal consequences. Research and development of mobile nuclear reactors that can be integrated into a spacecraft also require a lot of money. Let's hear what you think of Russia's ambitious plans to put a nuclear reactor in a spacecraft in the comments section below.